the Chief Technology Officer at Brighthouse Automotive. Through the years, you would have seen presentations by me with various different companies, Dimension Data, Automate, Brighthouse. It's actually all the same place, right? We just have a bit of a issue in what we call ourselves, but we do some interesting stuff. So I want to chat a little bit with you guys around complexities of system integration. So, like usual, I'm going to come with a lot of problems that I want to throw out there for you guys. I'm sure you're very well versed in all of those, and you know, we've seen quite a lot of them. I'm also going to try and give one or two potential solutions to things you can do. But the purpose of this is not being a full-on technical session, and this is the be-all and end-all of solving integration problems. It's more a session around, let's think about the type of things that we see happen out there and consider, you know, how we solve it. And in some cases, I've been told in some projects that you don't actually have to solve all these problems. It's debatable at the best of times, but let's go. So we're going to do a quick little introduction on some of the issues and the thinking and why we do these things and why we want to integrate software. I'm going to have a very quick look at some typical integration issues. Going to touch on synchronous versus asynchronous integration. Obviously, data integrity is a really important thing. Transaction management and how we do that across distributed systems. Some performance considerations, and obviously, whenever we talk about these kind of things, security must be top of mind, right? Whoop. Okay, so what are the goals of system integration, and why do we do this, right? Why do we not just build everything into our own system? Well, it's generally to augment data or processes between multiple systems. Not everyone can be experts in all fields for, you know, all the verticals out there. Go to the best of breed, integrate it to your system, and have a great solution that you provide to your customers. We need to ensure that different systems can exchange data seamlessly. The data needs to remain accurate, consistent, and up-to-date across all the systems. Now, this specific point is actually something that's quite contentious generally, and it's up-to-date and real-time, and what different systems and people see as real-time, right? Because you could very easily end up where your primary system is really a real-time processing system, but the system that you're integrating with is a batch system. So now you've got stuff you're chucking into ether that has to be processed at some point and manage that transaction should anything go wrong there back to your system. All of this adds quite a level of complexity, right? So we obviously need to optimize performance between the solutions. You need to do this in a cost-effective way. And there's a couple of ways of doing this, right? And probably the most important reason for integrating is there's a system out there, there's knowledge out there, just use it. So you get the communication between the systems, leverage off of those services instead of trying to build everything yourself. We want real-time data flow. And very importantly, we need to try and reduce the risks that's associated with system failures, security breaches, performance. Because the master of your destiny is not you anymore as soon as you start integrating solutions, right? There could be third parties that could have a knock onto another third party. And we need to try and manage all of that in a way that we can still protect our user experience or the value add we do as a system. So what are some of the pitfalls we generally get into, right? Most of the times, if we don't have clear integration goals and objectives, we see a lot of development going, a lot of things getting bolted together in a very, very clunky fashion. And yeah, you would get some results, but it's not really a usable system at the end of the day, requiring a lot of rework. Inadequate planning and lack of comprehensive requirements. I mean, you guys all know this story, right? We think we know what we're going to do. We're going to dive in and we're just going to go. 6 months down the line, we actually don't have a running system because we didn't actually just check what it is we really wanted to do. Neglecting data mapping and transformation between systems, right? And this is really something that can become a big thing, especially if you start mixing technologies, because different technologies treat data types differently. You can lose quality of the data. You can actually lose segments of the data. You could end up pushing data into their store that takes up more space than it should. So there's a plethora of impacts that you can push downstream if this is not thought through and agreed up front. So failing to design for and address security vulnerabilities obviously can expose sensitive data and compromise the overall solution integrity. The previous speaker actually had quite interesting statistics about all the attacks that happen at the moment. It's scary numbers, right? And the biggest way to get not even your solution, but your company and your reputation down the drain is overlooking security and being a victim of cybercrime, right? So another thing that personally I saw through a couple of projects that was really something that hurt us in the long run was just inadequate documentation of the integration processes. So one of the partners had a really mature, long-running system, massive system, hundreds and hundreds of integration points and services that was available, but they kind of just took some of the stuff and chucked it over the fence and said, well, here's all our APIs, go ahead and go do what you need to do. And obviously these things also grew over time, and there's a dependency between the services, right? So we ended up implementing, say 3 or 4 different services to achieve something that another service just does out of the box. But because the documentation didn't state it clearly, everyone is just all over the show. So that's really what we're trying to do, right? Now, in reality, we're trying to balance a couple of things, right? So from a business perspective, obviously time is a really important factor, both in terms of your go-to-market quickly to get it out there, get revenue, and the time to develop tailor-made solutions, right? And you're pairing that off or comparing that with the time it takes to integrate with a solution that someone else has got. The other side of this triangle is from experience. Various systems generally exist, and most of the time you're going to be dealing with legacy systems. It's not very often that everyone just starts rewriting new stuff. So do you have experience in interacting with that or modifying that system? Are you the guys who's got the industry knowledge and the experience to maintain this and to build out on this? So most often you can actually extend and not replace what is there. If we take multiple systems, bolster, bring records together, augment some data, you actually end up with a very nice solution that's wrapped with various systems, but you don't have to develop yourself. And then quality of information and data integrity, right? So I just said now the augmentation of data that you can get to ensure that you build up a really valuable data stream at the end of the day to make some very good decisions on. And this can all be done obviously by automating processes and having specialized streams. So the trick of all of this is obviously to manage these 3 components, so time, the quality of information we've got, and the domain expertise in a way that's cost effective for your own company and obviously for your customers, right? So some of the pitfalls in reality, and you guys know this, right? You always end up with performance issues, cost overruns in projects, security concerns, maintenance nightmares, data inconsistencies. I mean, the list goes on and on. And for all of these things, really, it boils down to communication and planning, People make assumptions that either we've got the ability to do something, which we don't, or we fully understand what the partner is saying we need to do when we integrate with that, and we actually don't. Most of these problems can really quite easily be avoided by understanding the entire solution, so not only your portion, but the entire landscape, see what the impact would be with whatever you do from your side, right? So it could be that you're a web front end, maybe for an auction system or whatever it is, and you need to push financials into an ERP of some sorts. But the rate of data that you get into the pipe that you stream through to your integration partner just cannot be handled by them, right? And without fully understanding this, you are creating a performance issue of some sorts, but you're actually killing the other system as well. So then you've got to start looking at how do we introduce a queue of some sorts, and what is the impact of it not being fully real-time, and understand and balance the trade-offs between those. So what are some of the typical issues that we see? Firstly, is performance and its introduction of latency, right? So implementing and maintaining a single solution is really very simple, right? We all understand how to virtualize our own environments. Well, I suppose whether you're on the cloud or on-prem doesn't really matter, but you understand, and there's a lot of skill, even at this event, talks going on with people, how to optimally configure these environments that for your specific solution, it'll work fine, right? It's not really a difficult thing to do. So generally, if you've got a well-tuned environment and your code is semi-decent, then you can have a good night's sleep, right? It's not a difficult thing to maintain. Something that does add a level of complexity is obviously the network layer, especially the last mile of connectivity could be quite challenging. And it is really a big culprit for latency and slow performance. And also just the quality of those lines, right? Where, again, if you're dealing with a single instance, it's probably not such a big deal. But if you've got multiple instances and systems connected to each other, you're moving a lot of things through the network that actually slows down the systems. So, like I said, as you add integration partners, now you've got a black box. So in this case, we've got 2 additional systems that we're integrating to, and we actually have no idea what it looks like. We don't know if it's maintained properly. You're hoping that they've got good backup strategies and tunings and all the right things and redundant lines and all these kind of things, but you're probably not 100% guaranteed, right? So now you're actually moving really out of the realm of the integration process and the actual development to start looking at SLAs and proper documentation around what is the environment and the services to augment the development process. Not typically something your developers would get involved in, but if this is not done properly or at least top of mind to ensure that you've got some form of downstream reliability, you can end up with a failed project, which is really not the fault of the requirements that you have for the function you're developing or the developer, right? Quite an important thing to keep an eye on as well. So another thing that kind of contributes to some of the problems we see is either what is being monitored or no monitoring at all. So the point I want to do with this is just actually run through a couple of things that is nice to look at and to consider to ensure we know what's going on in our integration environments. So response times is a really good metric to look at as a starting point, right? If you get a slowdown on your response times, all of a sudden, you went from millisecond to kind of hundreds to thousands to seconds, something is happening downstream that you've got to sort out, right? So keeping an eye on response times is good. Throughput, so the number of requests or transactions that go through your system or that integration point at any given time during the day could actually help you understand whether you need to scale up or scale out. If something went wrong, so you've got a queue backing up, or something's just changed you're not aware of. Resource utilization, so keeping an eye on your CPU, memory, disk I/O, network throughput, obviously. These are all good indicators for something is bound to go wrong, right? If your system generally on your infrastructure runs at a 20% utilization of CPU, all of a sudden you shoot up to a 70 or a 90, it's probably indicative that somewhere something went wrong. You probably had a memory leak or there's a long-running service. Something is going to go wrong. Generally, your solution components, so your database, app server, the web servers, keep an eye on them to see trending data over time. Is there any funny fluctuations that's coming up? Or is your environment still in a kind of green state, doing what it should? Service dependencies, so the health and performance of external dependencies provide valuable insight into potential issues. So again, the more insight you can have in whichever way, so the dashboard or whatever it is, to some of the downstream services and your integration partners, the easier it is for everyone to kind of guarantee the quality of your entire solution. Because again, you can see the train coming. Error rate, so track and minimize database, HTTP, and application-specific errors. And one thing that's also, and it's a personal gripe for me, I don't know, I'm maybe not the only one, but especially around your error rates and the management of errors. We know it exists, but it's not likely to happen, so we kind of just park it to the side, right? We don't monitor, check log files, and actually have a dashboard to accurately say, well, we thought it's going to happen once in a blue moon, but it actually happens 1,000 times an hour, right? And now we don't have proper error handling to that, so we're just chucking that thing into ether, and it becomes a nightmare to actually debug this thing and get it working, and you're patching and bolting, and everything just hurts, right? So keeping an eye on errors and the type of errors and the occurrence of them over time really gives you good insight into your solution. So downtime, keep an eye open for regular downtime. Again, maybe there's specific components, it's not tuned optimally, it's not scoped right for what you're doing. And again, if you don't keep an eye on it, well, it becomes tough to deal with it later, right? Network, I mean, always keep an eye out for latency, data loss, corruption, timeouts. Because in any software solution, right, as soon as you start getting any form of network in play, that is really your first point to go look to for performance stuff. The hardware, your CPUs and the memories and stuff is really lightning fast. Disks these days are really lightning fast. As soon as you get into network, things can go wrong very quickly. And as much as I don't know if there's any network guys around, and I know they defend their networks at all cost, always start looking at the network. So what are some of the other things we probably need to be looking at? Logs and diagnostic data. So keep an eye on those. Use tools to, sum up and provide insight into what's going on into your logs, because a lot of things, again, gets written into these files. And if you don't have a handle or a nice way to get proper information out of it, it is just another black box, right? I mean, these log files can grow to hundreds of thousands of lines of logs in a matter of minutes. So if there's no form of intelligence behind it, you're probably going to lose out on a wealth of information. Security, monitor for unusual activities and security breaches that could impact your performance, your reputation, confidentiality, all those good things that we keep hearing about this, right? Keep an eye on security. So having alerts and notifications, it's nice and it's a proactive thing to do, and we really need to do that. What I've seen a couple of times in some of the projects we were busy with is guys had a plethora of notifications and alerts for all the right people, but they don't have a process to deal with them. So it would end up, we getting high CPU somewhere. Oh, okay, that's great. Cool, let's wait for it to happen. Where, in reality, if they had a process to say, kind of like what pilots do, right? If they can land a plane, there is a list of things that they follow religiously, right? And that's why planes tend to land successfully quite regularly. If we do that kind of approach with the alerts and stuff, we actually have a purpose for doing what we're doing, and then, we'll probably get ourselves out of trouble. Capacity planning, keeping trend data and looking at trend data and to try and predict where you need to be will also help with your capacity planning and hardware planning and cost overruns and all those kind of things. Again, it becomes quite complex when you're working in an integrated environment where you may or may not be in control of the entire solution, but having a way to have an interactive conversation with your partner in this really helps your cause to be sure you've got a stable system. Okay, data inconsistencies and compatibility issues. So different systems may use different data formats or structures, making it difficult to transfer between systems. So I did allude to that a little bit earlier about your different data types, different technologies, older systems, more modern systems. I mean, there's a lot of things that can go wrong. So the important thing to consider here is be sure that you agree on an exchange format. It should be a widely supported and compatible format that's generally out there in the industry, not just between the systems you're using, because the more mainstream it is, the better the chance that if there's any issues with them or vulnerability that could be introduced by your exchange format or encryption layer that's going to add, whatever it is around it, if it's mainstream, it's more likely that it's going to be dealt with in a way that's appropriate. Your exchange format should be clearly defined, indicating how data type transformations should be handled in both systems. So, and again, this is one of those horror stories that I probably shouldn't have seen in my life, but we actually did see. It is something as simple as we had a numeric value in the payload that we sent across, and we just assumed, like all good things in life, you make assumptions, that the recipient of that data would understand it's a numeric value and we'll treat it as such, right? They ended up reading that thing in just a straight straight character or string variable, did some interesting stuff with that, and ended up losing a lot of the precision of that value, causing massive issues that took us months and months to find, because it is little chips away everywhere, that a slight imbalance here, slight imbalance there, and really just because we didn't communicate between the partners what we should be doing with the data. The format should allow for future changes and additions without causing major disruptions. Different formats have varying overheads in terms of size and the data they require. So again, I mean, it's always a good idea to minimize the traffic and the size of the payloads you send across the line and integrations. If that's something that's not necessarily in your control, well, the one thing what you can control is just the overhead you have on the payload itself. So something like a XML is quite a heavy payload, where JSON is a lot lighter payload. Pros and cons to both of them, so I'm not punting one over the other. Everyone's got its use. But if you need to really tweak down, that's stuff that actually does make a difference. And then ensure that the chosen format supports the necessary character encodings. We're pretty lucky in South Africa. We don't have funny characters and stuff in our alphabets. I know through Europe it's not the same thing, right? So we generally get trapped with that problem. No, that'll work fine. And then another important thing to consider is just versioning. So plan for changing data structures over time and how this will be handled with your partners, right? There's no point that you've got the ability to spin off a version 2 or whatever of your service, and they can't, because we want to keep uptime on these things as much as we can. Yep. Then again, documentation. So clearly document the structure and the semantics of your chosen data format. And the documentation should be available to both the developers integrating the system as well as the people responsible for maintenance. Another painful lesson that we learned that I really don't want you guys to make again, right? So the original project developers had a really good plan and a nice data structure, and they understood the transformations and the mappings. Everything was great. Project went live, had no problems for a really long time, and then we had to do maintenance on it. All that knowledge was just gone. And again, people made assumptions, right? It's like, well, you know, what they did here really seemed like a bad idea. We shouldn't be doing this. Let's go make changes. Whole world came apart. If it was just documented up front, and they had the information, you know, okay, well, it makes sense why they did that, right? Little things that developers don't like doing. You know, we don't like documenting stuff. It's admin, but there is an important use case for it, right? And again, the structure, data structure transformations, it's really important to consider, especially if you're moving data from perhaps a transactional system into more analytical system, or an analytical slice of the data structure, to sit down and make the third party aware of this is how you should put your data together, right? This is the actual mapping. Because again, you can make inferences on data that leads to an unusable end product or data stream. So looking at synchronous and asynchronous integration a little bit, and maybe what is the use case for each. So just very quickly, I'm going to go through, I mean, you're all probably aware, but on a synchronous request, we make the request, there's some processing that happens in the different system, get the response back, and all the while, system A is just waiting for the request, right? So you've got some block time there. The benefit or the nice thing about synchronous integrations is it happens in real time and your response is immediate. It is suitable for low volume transactions and smaller types of transactions. It requires both systems to be up and running at the same time, which is a really important consideration if you need consistency across your transactions and 24/7 uptime. And you've got all the nice monitorings in place to see that downstream everything's working nice. This is really great, right? You get immediate feedback, ensuring that the data is consistent between your systems. Created a customer in system A, push some data to system B, there's something gets back. We're talking about the same record, right? So that's really nice. Generally, in a situation like that, as well, it's easier to manage your transaction. Should anything go wrong on the other system, you can immediately get the error that it's either not committed, roll back on your side, or it is committed, but we need something else. Where if we get into the asynchronous that we'll talk about now, the situation does change a little bit. Again, I'm not punting one over the other or saying one is right or one is wrong. What I'm trying to highlight with this is think about the mechanism and the type of integration that you're doing for the use case that you're doing it. There's some forms are suited to things better than others, and you can create headaches for yourself if you don't. So a good example for using synchronous integration is a payment port or integration with a payment gateway. So for payments where I took your card details, I told you you're going to get something, I processed, took money from your bank, and immediately I can give you feedback and on my system say, yep, we're good, your product is shipping, right? If we had to do something like that in an asynchronous way, I took your money, something goes wrong, I don't place the order, you're not going to be a happy camper, right? For asynchronous requests, we've got a request that we send between the systems. You get an immediate kind of response receipt to say, yep, I got this stuff. You could either put it on a queue or whatever it is the other system does. It can process a request whenever it's got capacity to do that without affecting system A at all. Once the processing is done, we can send another request, which is really a response to the original request that was sent to the systems. And all the while, your initiating application is free to continue with other processing or work that you need to do. Okay, we spoke about that. So asynchronous requests tend to be suitable for high volume transactions or transactions that take a long time to process. Can handle situations where one of the systems, downstream systems, are down, right? It's not going to help if system A is down. But generally, these things end up being queued somewhere or in a log of some sort where it gets processed over time. And if it's not a time-critical thing, well, it can sit there and do its thing. And as long as it notifies the initiating system when it's done, things can still be kept in sync. Excuse me. So it can cause data inconsistency if there's a delay in processing the data. Not a problem due to the design or thinking of synchronous and asynchronous requests. It's something we just need to be cognizant about when you're actually architecting the system, is plan for a delay potentially or a time period where your data may not be the same. Otherwise, you can create inconsistencies. So a good example for using asynchronous integration is processing of batch data or performing data analytics or anything that you can throw into a queue, really. So what are some of the pros and cons between synchronous and asynchronous integrations? So looking at synchronous first, you get immediate feedback. So it's really good, like we said, for the banking example, where you took a payment where you need to move on to the next action immediately based on the result. It is really quite simple to do. So you've got a very easy flow of control between the systems. A talks to B, does a thing, comes back, handshake's done, we good. There's a high level of predictability. Again, because of the simplicity of the nature, just on how it all slots together. Transaction management, we're going to deal with that a little bit later. There's actually some clever things people do around transaction management, but it is it is a lot simpler to deal with transactions across distributed systems when everything is done in a synchronous way through the value chain, because then it's really, you find the point of failure and just unbundle all the way back, right? Some of the downsides, it is of blocking nature, right? So once that request is sent, both systems needs to deal with it and successfully finish that task or transaction before processing can continue. Now, not necessarily a problem per se, because you can solve this problem with multiple servers and load balancing and all those kind of things. But if you look at an atomic level at your single service and what it's doing, there is a blocking nature you just need to be cognizant of. Because if you have enough traffic coming through your integration system and you're not dealing with that properly with the load balancers and all those kind of things, you could run into trouble. And it's quite vulnerable to the effects of failures, right? So if a downstream system is down, the upstream systems are going to suffer about that. You can't continue at all, the process is blocked. It's just what it is, right? It could be quite resource intensive, especially if there's high volumes of concurrent transactions, potentially leading to scaling problems. So for asynchronous integrations, obviously highly scalable, right? Because you're not expecting anything to come back. Something will notify you something's happening, so you can chuck things onto different queues or whatever it is, so we can scale quite nice. Is highly fault tolerant. because the two systems don't directly rely on each other. Some form of messaging will notify you what's going on in the background. The caveat to the fault tolerance, right, that is also not out of the box. We need to architect and design for this to understand that things can go wrong, and fully comprehend what the list of things is that can go wrong and actually plan for that and have our code manage that. If you just chuck it into ether again, you're going to have problems downstream. Then fault tolerance is out of the window, right? The nice thing about asynchronous integrations is you have a lot looser coupling between your systems. Again, it's really just a message you're firing off and you're getting some form of feedback back. We don't actually care in this case what the typical system B would be, right? They can replace that with anything as long as your protocols remain the same and do the same kind of thing. We're not going to be the wiser because you're not really expecting a specific response time. It's not a real-time thing. Anything can happen in the back end. I mean, you could literally have a guy sitting and happy punching if their system is down and sending back. It's not going to make a difference. So it is nice to have the loosely coupled feature to that. So some of the cons of this, asynchronous integrations tends to be quite complex, and there's a lot more things you need to manage to be sure that you actually tie up the original request with a response at some point to understand that there is a response that came in and how to deal with it if you don't. There's a delayed feedback. So this may need a couple of different solutions, right? So it could either be nice, shiny things you do at a front end if it's a customer or an end user that interacts with this, just to kind of keep them busy a little bit, or have clear feedback to them to understand you did an action, we're aware of it, we send it for processing, you will be notified as soon as we get a response. You just got to design a way that is actually quite clear for whoever's using it that, yep, we got it back, this is your response, right? So it's easy to leave someone in limbo with a delayed feedback. And there's some increased latency. So because asynchronous integrations do not provide immediate feedback, there may be increased latency in processing tasks, which is obviously not acceptable or good practice in all cases. Looking at data integrity, I think we're still doing good on time there. So we obviously need to ensure that our solution provides accurate, consistent, and reliable data across all the systems in the ecosystem. How do we achieve this? Well, implementing data validations, ensure that we do the data type validations, range validations, format validations across all the systems. Again, you want to agree this between all the partners and have a consistent implementation all throughout. Ensure that unique identifiers are used to identify records, right? So we don't duplicate records or update records. We want to know what it is that we're actually working with. So data encryption, implement encryption strategy on sensitive data to ensure you protect it against unauthorized access and interception of your data during transmission. Data synchronization, so ensure that your data is consistent across all systems and ensure that the data is correctly propagated to all systems. Data governance, ensure that data is managed correctly across systems, and data governance obviously includes policies, procedures, and processes. Now, somewhere where this actually becomes a real thing, right? Especially for us being in South Africa, we don't have the GDPR policies and compliance that you guys need to deal with, right? We do have a version of that, but it's not as strict as that. So typically, our implementations would only look at our local PAPIA or whatever it's called. Now we integrate with a European partner, right? So they're expecting certain things, and well, it may not necessarily be the case. So we got to ensure, especially if you through multiple geographies, that you comply to the strictest adherence, which I think generally is GDPR. Not so sure about all the others, but I think that's the big one. To ensure our data remains consistent and stuff, we need to standardize on data formats and ensure that all systems can understand the format you're using, right? Especially if we're starting to use custom types for various things. Be sure it's something that's actually implementable in all the systems that everyone can see the apple as an apple. One of the other complexities that we've seen over time is managing the varying business rules and ensuring integrity of our own data. So again, there's a bit of a story behind this, which, it wasn't all that obvious up front when we started. So we did work for one of the major OEMs in South Africa, for Toyota. And they had a very strict policy around how they treat certain parts of their data, right? So customer data is the be-all and end-all of everything. It shall always reside with them. They don't care about third parties. They will not get access, right? Second to that would be vehicle data, building up your big record. Everything's great. So then they started a new division that didn't deal directly just with retail sales, but it dealt with more of a rental model. And we ended up integrating software for them for a company based in Australia or whatever. That's a really good rental module system. In their world, they had exactly the same view as what the OEM had on this side, right? And now you're sitting with the business rule that says, we're changing data only in this system, or we're changing it only in this system. What they ended up wanting to do is having batch scripts running behind the scenes the whole time to sync something this way and sync it that way, and because didn't work out on paper, right? So it is very important before you get down the line as part of your requirement analysis to understand these conflicting business rules and either deal with them up front or understand that the partner you may be integrating to is not the way to go. We just need to be sure we understand the business rules everywhere. Obviously, communication and collaboration. If you have open communication between all the parties, the developers, the system analysts, the DBAs, everyone that's involved and has their say in it, your chance of success is just more likely than if you just rely on the fate of a couple. Testing and monitoring. Be sure to do thorough end-to-end testing, do load testings, and do it in like-for-like environments. So, and I think I do touch it a little bit later, but I'm not 100% sure. The one big issue that I tend to see with integration projects is if the provider of the integration is company B, they would tend to have quite a nice UAT or test setup that's away from a production, but they also have a UAT environment that's very close to production that you can test against. The flip side of that coin, we tend to see that there's only environment connecting from like a UAT, either into the dev environment or the test environment of system B, right? So now, again, you're not comparing apples and apples because there could be features that is relied upon by system A that is contained in system B in a way that's not fully tested, fully implemented, and the final product. And you're actually not testing the integration per se, you're just really seeing what it's doing in that specific instance, right? The code is moving in the solution so much. So having a strategy where you've got like-for-like environments for all the things you're testing. So if you're doing dev, test against a dev. If you're doing QA, which is a more stable, do it against the QA instance. If you're really ready for a pre-go live, try to do that in a UAT or a pre-prod environment, and not from a pre-prod to a dev to the other environment. Error handling, another big gripe in life with integrations is it is not always clearly defined how errors would be treated across systems. So it may be in system B, in the OEM example I gave just now, that something like, I don't know, your passport number, for the lack of an example, is a really important thing. And it will reject the update on the customer if it doesn't have that. System A doesn't really care about that at all. And it's like, well, I don't have it, so I'm not going to give it to you. So when that error comes back, we really just ignore it and chuck it into ether. And you actually can't complete the process on the other side, which could lead to nasty hacks of filling in data, making up stuff, breaking the full process that was supposed to happen in the other system. So defining a clear error handling strategy is really important. I know it was a bit of a convoluted example, but I think you guys get the point, right? Business rule mapping, ensure that the commonalities and the differences between the systems is understood quite clear, right? So what does it mean to book a flight in system A versus book a flight in system B, right? Is both of them considered maybe up to the point of payment, that you actually booked your flight, or is booking a flight on the other system really, I just want your details so you're contactable, right? Could have big implications downstream. So really just understand that it's like for like, same kind of process flow, and that it actually maps to what it is you want to achieve. Transaction management, right? So a transaction is a set of operations that's performed on data, typically in an all or nothing fashion, and all the operations must complete successfully or not at all, right? A poorly managed transaction can lead to data inconsistencies, lost updates, or duplicate records. I mean, we all understand this from normal programming. It's not a nice thing to live in. Where it becomes really interesting is when we do this across distributed systems. I'm only listing two potential possibilities that's really patterns that you can implement to deal with these problems. Maybe you guys have some other ideas around this. I'd actually be quite interested if you did it in another way, just to see what it is you did. But really, in the two-phase commit protocol, there's a transaction coordinator that's responsible to marshal the transaction across all the systems. So really, you've got a prepare phase between all the systems that sends a message for system A to prepare, system B to prepare. And as soon as there's a yes from all the systems, the transaction coordinator would then send a message out to both systems, say, okay, commit your data. If any of the participants responds negatively to the prepare to commit, a different message is sent to abort the commit in totality. Two-phase commit could be a bit of a performance bottleneck, especially if there's a high volume of transactions that gets through the system. If you have that constant way to sync up, you can land yourself into trouble. And it can lead to the reduced availability of systems because there could be quite a delay before everything syncs up and you can use that data again. The other pattern, which I quite liked, I think this is quite a good, usable, and a nice trade-off between the different ways, is the Zaga pattern, where sequence transactions could be interleaved with one another. The coordinator ensures that the transactions are completed successfully, and in the event of a failure somewhere, there's a compensating transaction to undo the transaction that you just did. So really how this would work is you've got, bit A, B, C, or 1, 2, 3. Each of these transaction or atomic transaction parts will have a compensating transaction. So if we get from T1 to T2, there's a failure there, we execute counter 2 and counter 1, and your transaction is undone. So you really commit in stages and have a way just to roll it back in stages that's consistent. So every transaction or atomic transaction, a part thereof, can be rolled back with a compensating transaction. Some important considerations when doing this, obviously your asset properties. All changes in a transaction needs to be committed together or rolled back together. Ensure that your solution or your data moves from one stable state to another. Isolate concurrent transactions from each other so there's no contamination of your data or overwrites, stuff like that. And once a transaction is committed, ensure that the changes are permanent and immune to failure of any sort. So if you have that final commit, then it shouldn't be possible for a compensating transaction to overwrite it or whatever it is. In distributed transactions, there's typically a coordinator and one or more participants. The initiating application sends a request to the coordinator, thereby initiating the transaction. The coordinator creates a unique transaction ID, and this is sent to all the participants. Each participant executes a transaction as a local transaction, and then once all of that is done, you have your completed transaction. Distributed transactions face challenges due to potential network failures, system crashes, and participants becoming unavailable during the transaction process. To mitigate this, again, look at robust error handling, limit the reliance on downstream services. So where possible, and that's where I say it up front, I'm not picking one over the other, but where possible, try to do more asynchronous type integrations and transactions where you're not reliant on downstream systems. Have robust logging and monitoring. And in cases where strong consistency across distributed systems is not absolutely required, use alternative strategies like asynchronous processing or event-driven and. So what are some of the other performance things we need to keep an eye out for? So data volume, obviously. Large data volumes can cause network congestion. So consider having some form of compression on your data, caching wherever you can. And even if it's required, do some data throttling, right? So that's something that we saw quite successfully with the example I had with the auction system. The amount of traffic that came in from the auctions was just so high that the ERP on the other side just really couldn't keep up, right? The only way we could solve that problem was just to throttle on the one hand and get batches through kind of as they require them, because not all the messages that came in was required in real time for them to continue with their business, yet it brought the entire business down if we just opened the floodgates. So data throttling is something you can consider in some instances. Latency, you need to minimize that as much as you can. And in this case, I'm leaning towards referring to network, but it's not only network causing latency, it's also additional process. It could be multiple microservices you implement where you could have gotten away with one, multiple systems that's part of the downstream system. All of these things add latency. Ensure that you keep that down to a minimum. And again, if possible, try and cache data where you can. Protocol overhead, we spoke about that earlier. Whatever you do, try optimizing your packet sizes and the network traffic to either get as much through in a single request as you can, or keeping them as small as you can to get it through the line quickly. Security requirements can affect performance. So, and this is quite a controversial one, right? I think the previous speaker that was here that did the security will probably shoot me for saying this, and I tend to agree, right? But as with everything in life, there's trade-offs. At some point, you kind of got to step back and say, well, we can't have the be-all and end-all security. It just has to be secure enough. And I say that very carefully because we need to be sure that it's proper and not just a bot's job. But that you've got enough security to be sure that the solution is still efficient and effective with what it needs to do, but still protecting the data, right? So there's not really a be-all and end-all. We need to satisfy all 500 security requirements necessarily. And on the other side, it's also not, well, this thing has got to be, 1 or 2 millisecond response or whatever. We need to find that trade-off and understand the price we're paying for the integrations. Ensure that the system capacity is sufficient to handle increased workloads. So again, monitor the system performance, see the trends, see how it's changing, and optimize and plan your capacity on fact rather than on gut feel. Errors occurring during data transfer affect system performance. So, error handling, and we do things, but you cause blockages, right? So either you don't handle the error at all, which is a bad thing, right? Or if we handle the error but you don't do it in an efficient way, you're actually also causing performance issues. So with all of these things, and it's these type of stuff, right, is really stuff that I found the general developer out there that we saw don't necessarily think of all of these things at once. We've got a requirement to get a service to get these two systems working together. And from a business perspective, it's great. It makes sense. And by version 7, one by one, we started addressing all of these, and now we've got a good, efficient system, right? And that is really where the architects and your analysts need to guide a little bit more and make it visible to everyone in the process that, all these things on its own is important, right? The infrastructure the solution is sitting on is important. Not for your day-to-day job, but understand the implications in the total solution and design and work around it. So the last thing I want to chat about is just some security. And I got security twice. Some security considerations. So we're doing security and security considerations. It's secure stuff. Some of the business impacts that we can have based on security breaches, and if it's not implemented properly, right, is it could be massive financial losses for the company. In terms of remediation, it could be in terms of a ransom that they want to be paid or whatnot, and even if you don't get into that, just understanding what the problem was that caused it and remediating the specific kind of the hole you had in your security is a timely and costly exercise. And you actually haven't even dealt with the damage that occurred because of the breach, right? There could be legal costs involved. Potential litigation can result from either regulatory non-compliance or lawsuits spawning from people who had their data lost. And restoring systems to normal operating time is time and resource intensive, right? So data recovery could take quite a while to get you up and running again. There's also reputational damage. Customers, partners, and stakeholders may lose trust in your ability to protect sensitive data. Media coverage of the breach can really damage your reputation as a company. And the breach can impact the brand value and equity for many, many years to come. Now, you may be thinking, we had an Open Edge conference, we want to talk about developer stuff. Why are we talking about financial losses and reputational damage? And it's, again, just to reinforce the fact, right, that everyone in the value chain, from the initial design straight through the end delivery, needs to be cognizant of what can happen if we let that one little thing slide. Think about this up front in design, because after you've got an implemented solution across multiple systems, and that's really great, you have to start putting in additional security layers and whatever is required. You're going to end up to a point where your integration is actually just going to become so slow with the latency you're adding or workarounds you're adding that it's actually not workable anymore. So it's good to have these things top of mind as you go through the process and understand the full scope of the integration you're doing. So there's potential operational disruption. The breach may necessitate shutting down systems or services, and users may be unable to work effectively during the breach response. So impact on your customers. There could be breached customer information that could lead to identity theft, fraud, financial losses, et cetera, et cetera. So, the web that we span across this really simple payment portal we implemented now could be impacting each and every one of you 3 or 4 years down the line. And I promise you none of us is going to like that, right? And breaches may expose personal information, could be medical information, or any type of thing that can lead to potential harm to individuals. So again, if we look at the more malicious side of things, if I have perhaps some medical information about one of you, and there's a group of people and there's a trend that's coming out, I may want to start as a hacker, start attacking some medical institutions, right? Because there's a very high likelihood that I'll get a ransom from them to get their money back, because we don't want a loss of life somewhere, right? Again, it's the softer things we don't tend to think about when we do these systems, right? So security impacts on the system or the solution itself. So obviously data exposure, you can lose sensitive data and the flow between integrated systems. You could also expose some business process because of this, right? Generally, for most people, I would assume in this room, if you get a nice data structure or get insight into a certain process, there's a high level of reverse engineering that can be done. And in the competitive business environment these days, that could lead to serious damages for a company. There's an increased attack surface for integrated systems. Again, it's not only your environment, your hosting environment, your code you need to protect and think about. There's also all the downstream partners and the multiple entry points for attacks. A breach in one system might provide a foothold or further attacks across other systems. Now, this point is actually a lot more sinister than it kind of stands out there. But you know how many times we've seen that, right? So there's really good protection at your network layer through firewalls to get into the initial system. But once you're in on that initial resource, right, everything behind that on the network is just plain open to all the others. So if the attacker finds a way to get into that first entry point on that first server, it is free for all after that, right? And again, be sure we minimize all the risk through the entire solution, not just the actual integration that we started talking about, right? It can lead to data integrity issues. So not only can they steal your data, but they can also manipulate data, which could it could hurt in so many ways, right? Because you could be making financial decisions based on certain numbers that could have been changed. It could actually end up hurting a company or a sector really bad. It could be like the medical example we used earlier, where certain ranges of stuff is just changed on customer profiles or patient profiles, which actually leads to loss of life. So it's not always just losing data, locking up data. It's actually any change on the stable state of the data that could cause problems. There's obviously long-term repercussions for the system as well. So if breaches are not properly identified or addressed, there could be long-term vulnerabilities that's open that someone can attack at a later point. Then prevention is better than cure, right? So threat modeling and risk assessment, do this regularly, think about this the whole time. More so when you start putting multiple systems together in a single solution. Identify potential threats and vulnerabilities, assess the impact and likelihood of each threat to prioritize the implementation and fixing of the problems. Implement secure development practices. So follow secure coding standards and guidelines preventing common vulnerabilities. Do code analysis on the software or on your code to be sure that we're doing things right, we should, right? Authentication and authorization. Implement strong authentication and authorization mechanisms to ensure it's only authorized entities or users that can access your services or data. Use role-based access to control and restrict specific functions or executions of functions. And this is really quite important, right? Because it's not just understanding that, yep, you're authorized, you can actually use the system, but it's also that you limit based on what it is that you expect it to do with that information to say whether you can or can't, right? And then obviously implement data encryption and security across your APIs. Use API keys, tokens, or OAuth for access control and ensuring your data integrity. Always have an incident response plan, right? How many of the guys of you in the room actually has a good incident response plan for your organization? What? So I'm glad there's people. As I stand here, I have to admit we don't have a comprehensive one either, so I'm guilty as. But it's, you know, we really need to know to the T what it is we need to do when things go wrong. We tend to err to the side where, well, it's probably not going to happen to us. You know, we live in the open edge environment. It's nice and safe. We're running on Linux servers. It's nice and safe. And then something happens and everyone is scrambling all over the show. Prevention, again, is understanding what the next steps is will all help to ensure that you get your environments up and running and deal with the threat as quick as possible. And then obviously, if you have the plan, regularly review it and update it. Things change, technology change. Be sure that it's a live working environment. So the final thought that I want to share with you guys, and again, I did allude to this a little bit earlier, but it's such a thing, I'm putting it up there again, right? Ensure that you've got the right environments to develop, test, check your securities and the assessments and like-for-like environments across every component in the solution. Again, don't do a development to a UAT, because what you'll typically see in a development environment, right, is there may be potential stubbing to certain things. So we could have system A, B, and C. I'm testing the integration between A and B, but there's a stubbing of the service between B and C. So you do get the right response this side, but you don't know if something happens downstream, what is the impact going to be, right? Test integrated to the partner test environments, and then in the UATs, I mean, you don't want to see any of this stuff. You don't want to see stubbing. You want to see real time. If I send my data from this end, what is the journey? What is the performance like? Does it come through as one consistent transaction, and my data good across all the systems? And that is it. So if you guys have any questions, perhaps thoughts, comments, just integration and